All right, Dennis, it's all yours.
Thank you, Grant. So initially on the schedule, it said that this talk was going to be about integrating Pulp with build systems in general. But while I was preparing this talk, I decided that there was enough to say about Copper and the journey we went on to integrate with that service that I would simply focus on it. Um, so who am I? I'm a principal software engineer at Red Hat. I've been contributing to Pulp projects since 2014, and I was lucky enough to be able to start operating it at Red Hat in 2023. And this service is serving the needs of teams within Red Hat. It powers a service called Content Sources that is for Red Hat customers. And then we had an opportunity to integrate with Fedora COPR. Fedora COPR, well, let's go talk about the agenda first. We're going to talk very briefly about what Fedora COPR is, and then we're going to talk about the challenges that such a large service brings with it. We're going to discuss the features that were inspired by the problems we encountered during this integration. We're going to discuss deployment changes that we had to make to our service to accommodate this large load. And we're going to talk about a couple of application changes that Copper had to make in order to make this integration better. So what is Fedora COPR? It is a build system that is publicly available to all Fedora users that want to upload a source RPM and have this build system build an RPM and make it available in a repository for DNF to consume. And there are very many users that use this system, which means that there are many repositories. And most of these repositories are actually pretty small. However, there are many repositories that are extremely large, like tens of thousands of RPMs large. And these large repositories, I would say, prove to be the most challenging for us. And what was challenging with them is that the content in them is constantly changing. Users are able to build new packages. They can remove old builds. And this happens with users from around the world. So this is happening all the time. And the last challenge for us was that we needed to make sure that this was publicly available without any sort of authentication, meaning the repositories that are already published with metadata needed to be publicly available, unlike the other users of our service that wanted things to be behind authentication. So as we started working on this integration, we quickly discovered that Copper as an application would need a way to keep track of which RPMs in Pulp belong to a specific build that is stored in their database. And so this meant that they would need to be able to put labels on every package that they upload to Pulp. Prior to Pulp Core 3.73, users could only label repositories and maybe distributions, but individual packages could not be labeled. And thanks to Grant, users can now label individual packages. And that has been amazing. That has allowed Copper to upload a bunch of packages and then find them using data that they store in their own database and either add them to repositories, or later when a user chooses to remove them, they use that same build ID to do the lookup using content labels. So this has I have now told pretty much every person that's been integrating with their service that they should label all the packages that they upload, because that is the best way to find that content and do things with it. So now that we were able to find all the content easily, we needed to upload a lot of it all the time. And what we discovered is that the package upload APIs that we had initially implemented in Pulp were not fast enough because they were all going through the tasking system. And this was by design because we wanted users to be able to add things to repositories, and any operation that changes the content set of a repository needs to be performed in a task. But this didn't scale. The number of uploads that COPR needed to do just did not work with everything going through the tasking system. So we added a synchronous upload API that allows users to upload orphaned content and then later add it to a repository as a big set. And this significantly reduced the number of tasks flowing through our tasking system. As our integration was going, the size of Pulp's database kept growing. The number of repositories, the number of repository versions, the number of packages, it just keeps growing with each day. And COPR is a big user, but there are also other big users. And so over a period of months, we noticed that tasks that needed to know what content belongs to a repository version were taking longer and longer to execute. And our analysis of database queries showed us that basically our queries to look up the content set were just failing whenever not failing, they were just taking a really long time with such large databases. So in Pulp Core 3.83, we added a new field to the repository version table that just stores what content is in there, so that whenever we need to find it out, we just do one basic query and we get the set of content in that repository. And that really helped with two tasks in particular: the task that creates a publication and the task that creates a new repository version from a base version. Anytime you would specify a base version for the modify repo API, it would just take forever. So both of those got much, much faster with Pulp Core 3.83. And over the last year, we've also made lots of incremental tasking system changes. The number of, even though we've reduced the number of tasks in Pulp from the API, with the synchronous upload API, there's still a whole lot of tasks. It's just unavoidable. And so we've been constantly making changes to the tasking system to make it more efficient and to allow us to have more workers. So in addition to features, we had to change our deployment. We had to add additional API workers. We run our Gunicorn workers with 5 workers. And then I believe there are 20 of these pods. So there's 100 API workers that are accepting API requests. We also added auto scaling of Pulp Core workers. And one of the tasking system changes that got made during the last year is that we've added this unblocked at field that tells us that a task got unblocked, and we are now able to see how many tasks are ready to be executed but are still waiting to be executed. And whenever we see that number start increasing, we are able to deploy more Pulp core workers so they can start picking up these tasks and executing them. Some of the packages that are uploaded from COPR and by some of our other users are just very large. And initially, we told our users that they should use chunked uploads API, which is what Pulp has available. And it allows users to take a file and upload it in chunks and have Pulp reassemble it. And once again, go through the tasking system. And while discussing the issue with the maintainers of COPR, they explained to us that for their users, they just set really long API timeouts of 30 minutes. And they just basically allow users to upload gigabytes of data at a time. And so we worked with other teams at Red Hat to configure the gateways that we accept all the traffic through to allow these long API timeouts. And so now we also support this. And COPR uploads very large uploads. They don't take 30 minutes, but they do take multiple minutes for these gigabytes. And that's been really helpful in simplifying their application logic because all the calls have the same workflow. They just use the same API to upload the package. And then whenever they have a set of packages that they finished uploading, they create a repository version. We also had to limit, we had to work with the gateways to change the rate limits. The gateways that we're using are not designed, they were not expecting so many API requests to be coming in from the same user. And so we had to make sure that we were able to accept all those without all of a sudden COPR getting a 403 and having to do a backoff. And that's been also very helpful. Whenever we were trying to figure out how we're going to make these published repositories available to the users without any authentication, we came up with a naming convention for domains. And I have to mention that our service isolates all our users using domains. And that domain name is part of the URL space, both for the API and for the content app. So now, if your domain in our service starts with public dash, the repositories that you publish are available without any authentication. And that's been working really well because there have been other upstream projects at Red Hat that have wanted to do that. And we were able to accommodate them very easily using this naming convention. As we've been doing this auto scaling of our Pulp core workers, we've discovered that we basically have outgrown the shared cluster that we're using. The OpenShift cluster that we've been using has been great, but it has limited resources because they're shared with other services that are running on console.redhat.com. And so we are now in the process of migrating to our own cluster, which is going to allow us to have even more control over all the settings that you can have at the cluster level. And so that's been great because our goal is to eventually have 500 plus workers, and that's going to require a lot of RAM and a lot of CPU. Because some of these repositories that our other users use for syncing content, they require close to like 5 gigabytes of RAM. And so our own cluster is definitely the way to go. So as we made all these changes to Pulp's feature set and to our deployment, we still were having issues with, well, the biggest one I would say was the tasks. What was happening with these large repositories where there are thousands and thousands of RPMs is that the application code in COPR would upload a package, and it would then, or upload a few packages, and then it would ask Pulp to create a repository version. While at the same time, another builder in COPR would finish building some more RPMs. It would upload them to Pulp and ask Pulp to create some more, another repository version. And then after each repository version creation, it would ask Pulp to create a publication. And what would happen on a repository that hosts basically the whole Python stack is where we really experience this, is that we would basically have a bunch of tasks queued up that would create a repository version, create a publication, repository version, publication. And it was untenable because it's not cheap to creating a repository version is relatively cheap, but creating a publication is not that cheap. So this problem was already experienced by COPR with their previous storage system, and they had used Redis to batch the create repo C calls. And so I helped contribute a new feature to COPR to do the same thing with Pulp. And so that same Redis that they use for their file system storage backend is now used to batch repository version and publication creation in Pulp. So that before asking Pulp to actually create a new repository version or a new publication, COPR actually checks Redis to see, hey, were there any other requests to do this? Oh, there were. Let's put them all together and ask to do it one time. And while that is running, more of these operations are queued up in Redis. And then the application, once again, whenever it wants to create another repository version publication, once again, takes a batch of these and submits them to Pulp as a batch. And that has really significantly improved the speed with which the Python stack can be rebuilt. The multi-threading for uploads, we implemented that as one of the mechanisms for helping migrate existing projects, because COPR already has all these RPMs stored on disk, and we need to migrate them all to Pulp. And so I added multi-threading for uploads so that they can be done 10 at a time instead of serially. And I really recommend that to anybody that has a lot of packages to upload. So like some of the teams that we work with, they upload basically most of RHEL into Pulp. And they need to do this daily, sometimes multiple times a day. So doing that in parallel is important when you have, 7,000 plus packages that need to go in. And so those are the two main changes that needed to be made in COPR. And that's all I have. I think we have a few minutes for questions. Yes, Jared.
Is that multi-threaded written in Python as well?
The multi-threading is written in Python, yes.
Do you think we could add it to the Pulp CLI for our uploads, or?
It would be amazing if we did that, yes. We need to.
Have you opened an issue yet, Dennis?
I've not opened an issue.
Hint, hint,
What?
hint.
There is an issue in Pulp CLI. I know because I
Is there?
tried to do the work on it like 2 years ago, and then I found it very difficult to work with the multi-threading.
Well, one of the challenges I found with the multi-threading actually was that there was a bug in Python requests. We use client certificates and keys to do the authentication, and there was a bug where that certificate was not being properly shared with between threads, and we had to initially patch COPR. But then eventually Python requests did another release where they fixed that issue. But it was, we were getting these core dumps, and it was really interesting to investigate that.
David, go ahead.
Yeah, so great presentation. We were thinking about maybe setting up Copper at some point in the future, and I was just curious, are there any docs for integrating Copper with Pulp?
Are there any docs? No, but you mean you want to run your own version of COPR?
Yeah, exactly.
Well, I mean, there isn't really, I don't, we would have to ask Jakub and Pavel about docs. They definitely have docs, but it is a storage backend that you just enable. Whenever the Copper CLI lets you select Pulp as a storage backend, and you just set a little config, and it just works. So it's pretty simple from my understanding. I've actually set this up on my laptop as I was doing Copper development, and it's pretty straightforward.
Other questions, folks? All right. Dennis, thank you so much. That was a great presentation.
Well, thank you.
I'm going to close the recording here.